I work at the little school down the river from here. And we've been looking at this sort of panoply of technologies for quite a while. I run something called the Visualization Research and Teaching Laboratory. And here we're really looking at the full range of sort of the alphabet soup of VR, AR, MR, XR, HR. You probably don't even know what HR is, but we'll talk about it. And so today, what I'm going to do is take a look at our facility, which is kind of an interesting evolving space. But it's currently divided into our sort of back-end system where we're tearing headsets apart and we're building cameras and that sort of thing, which is on the research side. But on the teaching side, we have a sort of classroom of the future. Holds 18 to 20 students. And as you can see here, it has a front-facing 120-degree 8K 3D projection system. So this is an 8K front cave, as it were. And this allows us to combine access to materials on local computers in the lab, but also very high bandwidth connections to the outside world that allow us to bring other content up to and including 8K into the space in real time. We also have headsets for the entire class. We've got 3DOF Go's at the moment. We also support walk-around HTC Vive high-end headsets. And this is where we are sort of practicing how the future of teaching is going to unfold in the next few years when these kinds of pretty crazy things like 4K headsets for everyone, 8K 3D displays are relatively common and available for teaching. One of the nice things about combining a space, which is a kind of multimodal, multimedia space, is one can be in the virtual space as well as in an augmented space. And really, you think of the front-facing cave is a kind of augmented universe. But one of the big advantages is that the system allows people who are essentially the audience, the class, to see what's going on inside the headset environments. This is a really big thing when you've got people who are having an absolutely amazing immersive experience, but no one can see what they're seeing. So we put it up on the big screen behind them. We do that with a number of different applications, things we develop ourselves, but also we reach out and are really looking at what's going on in the world. So for example, Google Earth VR is a really interesting program. It can be used for a lot of purposes. It's just a generic informational database. Depends on what you want to use it for and how you want to, as it were, teach with it. We also are looking at a wide range of pre-existing and existing worlds, virtual worlds that are science-oriented, that are bringing in data sets which can be used for teaching. This is actually a world which was created in 2012 in Second Life by NASA. But we're bringing together this combination of real data, scientific visualization, and with interaction. We're lucky. I'm located in the Department of Earth and Planetary Sciences at Harvard, which is one of the larger science entities at the university. And we have quite a range of projects from subsurface earthquakes, looking at particularly Southern California and Japan, into oceanographic, atmospheric, but also planetary sciences. And right now we are supporting two projects, the Mars High-Rise Orbiter and the Jupiter Orbiter. So we're processing data that's coming down from those missions and providing it in either the front-facing 8K display environment, 2D, 3D if it's available, or in headsets, depending on what the need is. We also have a lot of Mars data from both JPL and NASA, and we are running a number of different kinds of simulators. And we bring students in regularly and allow them to drive rovers around the Martian surface to explore in VR, particularly this sort of virtual exoplanetary or, in our case, planetary systems. We also use this space that's between the class and the screen for doing both our work-around immersive VR, but also some other experiments. This is a virtual horse. We are working on virtual horses right now. Turns out this is a very interesting area. Humans have been getting around the planet on horses for tens of thousands of years, and the whole sort of history of mankind was often defined by how far away it was in terms of a horse ride. And it turns out this is very good for navigation and mobility in VR, where you don't have to break the immersion, but you can continue to move around a large space, as you'll see. This front-facing environment is really good because it gives the audience a chance to, as I say, be immersed themselves in the immersive environment that the student or the researcher is seeing in the headsets. We run wireless systems. These are the Vive Pros with a new wireless adapter. So we can put 2, 3, 4, 5, 6 people in the same virtual environment to explore. And it may be graphics, it may be pedagogy. We're also doing a lot of user testing of various types of systems, things that you'll use both in class or you might use in the library system, or you might use at home. We're starting to see students arriving on campus not only with smartphones and laptops and tablets, but VR headsets in their backpacks. This is our sort of working lab where we're, as I said, tearing apart cameras and tearing apart headsets. We have about 25 GoPros cameras, and we use them as Legos. So we build 3 camera VR rigs. We build 6, 12, and 24 camera rigs out of those GoPros. Cameras are changing so fast right now, you don't actually want to buy a camera. It's better to sort of build it or design it. On this particular wall, there are over 70 different headsets. We have over 100 different kinds of headsets in the lab across the full range of AR, VR, and MR, which we're evaluating for ergonomics, for affordability, for sustainability, and usability particularly. As I say, we run the gamut from the sort of high end to the low end. Teaching here is very much about using the models that are available. So this is Professor John Shaw, who's the chairman of the Department of Structural Geology, and looking at what's happening under Southern California in terms of earthquakes. Now here you'll see that the students, instead of wearing headsets, are wearing fast shuttered glasses. So when we do our 8K projection 3D, we use shuttered glasses for that. And it produces a result which is pretty amazing. Most people have never seen 8K, particularly projected on a 23-foot, 120-degree immersive screen, but then kick it into 3D and it gets even more interesting. At CES, which just completed, they were showing a number of 8K flat panel systems. Don't expect to see any of that in your hands or available anytime soon. But part of our mandate is to stay 5 years in the future. We're also teaching things out of the science domain. So in this case, French. French 3, we take the students to Paris virtually for an immersive experience, walking around the 11th and 12th arrondissement in Paris. And particularly, we've got an interesting project that I've been working on for many years with Professor Peter Manuelian on the archaeology of Egypt, and particularly Old Kingdom Egypt at Giza outside of Cairo, where the Great Pyramids are located. For the last 10 years, we've been rebuilding the tombs, temples, and pyramids at Giza in virtual reality. And we have those available in a number of different forms which are accessible. We've been running a class in conjunction with Jiang University and my colleague Changyu Diao, who's here today. And what we did here is we took a vision that Peter and I had. We have the 3D models. We want to run them, but we wanted to be able to not only give them and share them with this class, but to look at extension teaching and share it with other classes elsewhere in the world. So we ran a parallel version of the class with a group in China. So we have a full Chinese class sitting in one place. We have the Harvard class sitting in another. We connect them through a number of technologies, beginning with Zoom, which allows us to bring each student up individually at both locations. Here we have a 360 camera in both classrooms, in China and in Harvard. So the Harvard class is in the foreground. The Chinese class is a little further up. We reverse this when you go in the other direction, and you put the Chinese class sitting behind the Harvard class. Peter was then able to go into virtual reality, into our virtual tombs. We were able to create avatars for all the students on both sides, that is 20 in the US and 20 in China, bring those avatars with the teacher into the virtual tombs and have him give a guided tour. This is all in real time. We had to tunnel through the Great Firewall of China to do this, but that was something that was just a sort of small bump in the road. But this has allowed us to really look at how we can have shared VR teaching experiences that escape the confines of our space. Why China as a partner? This is what we're seeing today in Chinese schools. This is something we are not seeing here. You were seeing there a university. Here we're down to a grade school. We're back to a high school. VR headsets are now something which are widely accepted in China as part of your teaching environment. Now I'm going to flip very quickly and go over to the AR part. Since we are doing mostly VR for the last several years, we're now beginning to pivot to adding augmented reality to this and to look at how we can create content from the bottom up with the students, with the TFs, with the teachers, and where content exists in the world that we can bring in and use that. There's a lot of stuff for flat screen right now, which is very valuable. Flat screen is going to always dominate the AR space. We run an augmented reality sandbox in our space. This is something, our version of this came out of what actually was developed here at the Media Lab in the Fluid Interfaces group about 14 years ago. Hiroshi Ishii developed the first of these augmented sandboxes. Essentially, it's real sand, it's a projector, an Xbox camera, which is developing, looking at your altitude of the sand, and creates real-time topographic maps. You then can put other algorithms on top of that, like a water sim, or in some cases, a lava sim for volcanoes. This is the standard type of classroom that we have for science, that is for science laboratories. And what we're trying to do now is convert these into virtual science experimental stations and spaces. And so we'll be doing that by essentially making the bench itself smart or intelligent, by putting computing capabilities into the bench, using short-range, short-throw connections between these small sort of Steambox Unix nodes that sit under the table to various types of headsets. The headsets might be AR, they might be VR, but they need to run on the same infrastructure. So that's one of the things we're concentrating on is what's the cloud architecture for AR and VR? What's the edge computing architecture for that? How do you get these signals from the cloud down to the classroom and down to the student with very low latency? So we've been doing a lot of experiment with that. A little shout out to one of our collaborators here at MIT, Scott Greenwald and Wiley Corning and the group in Fluid Interfaces, who are doing electrostatic playground. So while we're working on the infrastructure, how do you scale and spread and use virtual teaching and science for thousands of students? They are looking at the content, how you develop individual courses. Another talk which is coming up later today by Ilian Radu, who's also a researcher at Harvard, again looking at teaching with AR. This is sort of where we found it a few years ago. This is 100-year-old technology for presenting molecules. We've got to bump that up into the future, make that all virtual. We know this works because there's a lot of commercial outfits that have been doing it and other academic research facilities. We have to figure out how it works with the pedagogy at Harvard. How do you integrate this into existing courses? Faculty are not going to change what they teach. They may change how they teach it, but they're not going to change what. So we're very much looking at that. Virtual geology, this is one of the core uses of our facility, is how geology is changing, how we're looking at the world, how to bring the virtualization of the laboratory into the field, where you're looking at the rock face, you can actually pull from data sets information, overlay it as to what you're looking at, store it for later researchers. We do a lot of virtual field trips. I've got an expedition out right now with cameras. We equip all of our expeditions with 360 cameras these days. We bring it back and allow other students to virtually take the same field trips. Right now, one of the questions that everybody here, I think, will be talking about today is, but not necessarily in the case of education, but where is this space between the headset and smart glasses? And actually, these two are converging, and they're converging pretty rapidly in terms of capability. The landscape in sort of the technical landscape of VR and AR are going to get more complex. They're not going to get simpler. Here's some of our AR headset collection, which we've been looking at. And as some headsets shrink down to glasses size, which they will just very naturally, there's other reasons to maintain things at a larger size. And for example, here on the left with the Metas, you've got a shadow catcher, you've got the Lenovo. Actually, the clear plastic viewers turn out to be really good in terms of a scientific thing for working in a laboratory, think safety type of thing. We're running a wide range of gear that we experiment with and we look at. And periodically, we have to step back and actually do things which you never get to see in Star Trek. You always want to see in the background. Some engineer goes back and has to realign the holodeck probably on a regular basis. We do as well. So the future looks really bright and interesting. Paraphrase Haldane, the future is not only stranger than we can imagine, it's stranger than we can imagine. And if you take a look going forward, there's going to be a very interesting intersection between high fashion and high technology, which is going to dramatically change how all of this gear that was previously designed by nerds who didn't care what it looked like or felt like, it's actually going to become a really exciting area, and it's going to dynamically change what we can see in the future. So stay tuned. It's going to be a wild ride. Thank you.